Hello guys, welcome back to my channel Algorithm Maths. My name is Hassan Khurram and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach Tableau, our data visualization tool. So if you want to learn data science, I request you to subscribe to my channel and hit the notification bell icon button. So for today's tutorial, I'm going to teach you how you can actually implement a linear regression model on a marketing data set. I have actually produced a series of tutorial videos on marketing analytics where I teach you how to do data visualization, how to implement statistical analysis. For today's tutorial, we are specifically going to use a linear regression model and use that model to predict the price of total sales or total profit that a company made through a customer. So without further ado, let's directly jump back to our practical programming section. So the first thing we are going to do, we actually going to import libraries. The first library that I'm going to import is called ggplot2. ggplot2 is a powerful library that help us display powerful visualization. Then we have a library caret that is actually used to split the data set into training and testing. Then we are also importing library matrix that will actually help us evaluate the matrix of our linear regression model. And finally, we are importing library IR display. This is helpful when you are actually running the plots in Jupyter Notebook environment. Okay. Finally, we are calling the function options, which help us set the global options for our Jupyter Notebook environment. In this global options, we are actually setting the width to be 6 inches and height to be 4 inches for whatever the plot that we will generate in our Jupyter Notebook environment. Once you have imported the libraries, let me just run this block of code for you. The next important thing we are going to do, we actually import our data set. The data set in our case is stored in a file df underscore customer.csv. So in order to do that, we are going to use this function .csv read.csv and we will pass input argument the name of the file and we will store that value to variable called df. Okay, once we have imported our data frame, let's briefly visualize first few 5 rows of the data set, which we can do that by using this function head and passing two input argument. The first input argument is actually the data frame and the second input argument is the number of rows we actually want to visualize. Okay, so let me just run this code for you. Now you can see that our data set contains a number of columns such like customer ID, gender, date of birth, location, contact allowed, marketing channel type. Okay, out of many marketing channels such as organic search, affiliates, paid social, this particular customer was acquired through what marketing channel. So this column represents that this particular customer is acquired through organic search, affiliate marketing, and so on. Then we have first order profit, subsequent order profit, subsequent order counts, like how many times the customer bought from the company, whether he was a repeated buyer or whether he just bought for a single time. Okay, so it represents, like for example, for row 2 the customer has bought 7 times from the company. That being said, we have like total value of all promotion. This is like what is the offer that does the company has to offer to a customer in order to make him a repeated buyer. So it can be in terms of discount the customer offered to the customer and so on. Then we have age, what is the particular age of the customer, and then we have for total profit, which is our target variable, which we are going to predict through the help of linear regression model. So after visualizing our data set, let's move on and actually label our data set into training and testing. For this purpose, X represents the feature vectors that will be used in order to train the regression model, and Y represents the target variable that will be predicted by our linear regression model. Okay, so here I'm initializing a variable named X and I'm equating its value by calling the df data frame and then using this notation here with comma to actually extract specific columns out of the total data frames. Here we have like comma, value before comma represents row, value after comma represents column, and here we are passing a vector of column names to tell that we actually want these 3 columns to be extracted from the data frame df. And if nothing is written in the below before comma, it means that we want to extract all the rows from the data frame. Okay, so that's how we are creating our X variable. In the same way we are creating Y variable, but For y, we are only interested to extract the single column, which is called total profit. That can be easily be done by using this dollar notation and writing the name of the column. So we are here referring to df. This is the data frame, then dollar sign, then the name of the column, which in our case is total profit. So we have stored values in our x and y. Let's move on and actually use the caret library, and out of caret library we are going to use the function create data partition that will actually return us the indices in the form of vector, that we can use these indices to actually split the data into training and testing. So here we are calling function create data partition, and we are passing number of input argument. The first input argument is actually the list based on which you want to actually create the indices. Okay, then you are setting p is equal to 0.8, which represents the what is the portion of training data set you want to keep. In our case we are setting it to 0.8, that is stands for 80% data should be allocated to training and 20% data should be allocated to testing. Then we are setting list is equal to false. So now this thing here is important to understand. When we set list is equal to false, what this function will actually do, it will actually return us a vector of indices as instead of like returning us the actual y values. Okay, so it will be returning us indices values. Okay, so once we done that, what we are going to do, we are simply going to use this train index variable, and with the help of this train index, which is a row vector of indices, we will be able to create our training and testing data set. Okay, so in order to create our trained data set, which is represents the features that our regression model will use, we will use x square bracket, and then we will use this train index, which actually represents the row of indices, and comma colon, we represent that we actually want to take all the values that is currently present in x. Okay, so all the column and only those rows where train indices presents give us the row indices. Okay, in the same way we'll create y train with the help of y variable and then passing the indices, and the same way for x text and y text, where we are using minus sign, here it represents do not return those specific values that are currently present in train index, and only return those values which are not present in train index. Okay, so that's the use of negative sign here. So we have created our training and tested data set. Let me just run this code for you. Now, in order to train our linear regression model, so what we are going to do, we are going to initialize a variable name model, and we are creating its value by calling the function lm. Lm is a pre-built function in R that actually calculates the linear regression based on the data we actually provided. So the first value before the negating sign is called the target variable, which in our case is y train, and the values after the negating sign represents the features based on which the model will train and will predict the value. So in our case, we have selected three values, which is total value of all promotion, age, and subsequent order count. And after comma, we are passing an additional input argument, data is equal to extend. So we are telling that take the values of these three columns from this data set extend. Okay. That being said, let me just run this block of code for you. Now, once you have trained your linear regression model, now the next thing we are going to do, we are actually going to predict the value based on the X test, okay, which is the features that were kept for training testing phase. Okay, so based on that testing phase, our model will predict the Y variables, and we then later on we can actually compare the result by actual Y variables and predicted y variables. So in order to do that, we will initialize a variable named y underscore predict, and we are creating its value by calling the function predict and passing input argument. The first input argument is actually the trained model. Here we actually have trained earlier. Okay, and the second input argument is actually the data which we are going to feed as an unseen data, so it can predict the values of target variable, which in our case is total profit. So here new test data is equal to x test. That being said, let me just run this code for you. Now we are going to evaluate a bunch of metrics based on the linear regression model we have evaluated. The first matrix is called mean square error, which measures the average of square distance between the actual value and the predicted value. Then we are also going to calculate the root mean square error. The reason behind why we actually more focus on root mean square error, because it gives us the magnitude of conformability. Like it gives us the idea like how much the actual value will deviate from the true value. Okay, so give us an idea based on that unit basis. Then we have R square range values, which ranges from 0 to 1, where 1 means perfect prediction, 0 means that the model doesn't explain any of the variance. A higher value of R square that is close to 1 indicates a better fit for the model of the data. Let me just run this code for you. And after we are doing that, we are simply going to use cat function, and we are going to print the values of mean square error, root mean square error, and R square error by the use of this R statement. Now you can see that we have our mean square error, we have root mean square error, and we do actually get a very good value of R square score, which is 0.74, is approximately equal to 0.75. So that's it for this tutorial. I hope you are able to understand linear regression, and now you are able to implement a marketing data set and build a linear regression model that will actually predict the total profit made by customer based on these three columns: total value of all promotion, age, and subsequent order count. I hope this tutorial have been helpful. If you have any question regarding today's tutorial, feel free to write down your comments. I will be happy to help you out. In the upcoming videos, I will be posting more in-depth data analysis case study, where we'll actually take the data. We will actually take the project from the data wrangling phase up to the very last stage, where we actually create data stories out of the data we have, out of the results we actually get through our data analysis or data science techniques. So thank you for joining me, and I will catch you soon in the next video.